So I share my desktop screen. Yes, today I talk about create a metaverse by ourselves. And actually in our university, 3 months ago, we started developing our own metaverse platform. So and today I show you how we started creating metaverse platform, and I show you the current result. So before starting, let me introduce myself shortly. So in my case, after graduation, the graduate school, I started a game company maybe 21 years ago. And when we started our game company, there are only 4 members. And when I quit my previous company, and at that time, they hire more than 300 people. So it's a very big company. And fortunately, when I started my company, there are no commercial game engine for 3D game development. So we developed everything. We developed our own physics engine, rendering engine, databases, and game servers. At first time, it's very difficult for us, but later, after I moved to Dongsu University, it's great opportunity and chances for me because I know everything about the game build pipeline. And I worked more than 16 years in online game developer company in Korea, and I developed more than 9 games. Unfortunately, in Dongsu University, many professors have experience working in game company. Some of them work as a server, some of them work as a client programmer, and some of them work as artists. And this is why we started developing our own metaverse with Unity. So let's get started. Yes, so most of you are students. So I remember 30 years ago, I was also a student. So when I was a student, I want to make my own physics engine, rendering engine, and game engine. And to do that, we need to understand every detail of the graphics material and physics material and the mathematics. Yes, because you are a student, you may interested in making your own game engine, is it? But today, if you build your game engine from scratch, because there are many commercial game engine out there, if you compare your quality of your final product with the commercial engine, it's most, so as you know, it's not competitive. So I didn't recommend build a game engine from scratch. But as a student, we need to know the basic stuff, basic building blocks of game engine. So today, I prepared actually 3 stages. First one is very immediate, very basic level of metaverse platform. And second stage is intermediate level. And finally, the very high level. So today, I'll cover very basic level of metaverse platform. And it includes the mathematics and basic computer graphics and physics engine. And I skip the intermediate level. Intermediate stage means that the understanding the game engine stuff. So there are many features in game engine in Unity or Unreal Engine, and there are many good videos which explains the features of that one. So you may watch those videos. And then I show you, in my case, because I finished the courses as a computer engineer student, and I also majored the master's. I got a master and doctoral thesis in university, so I understand and I know every detail of the game engine, and also I have experience more than 6 years with Unity, so I know every features of Unity, and this is why and how I started making metaverse from scratch. But for you, if you are good at Unity, there's no problem. But if you are not good at Unity, try to familiar with the Unity features or Unreal Engine features. Once you got familiar with the Unity features, making a program with Unity is just fun and just playground for you. Okay, so first half of my time, I explain the basic part of the game engine. So this is a movie, Ready Player One, and you may have watched it. And I think this is the final goal of Metaverse. And in this movie, if the player wear devices, he jump into the Metaverse. In the Metaverse, instead of him, there is a one-to-one corresponding avatar there. And with this avatar, he can do everything like a real world. So our question is that how can you implement this kind of stuff? So actually, it's very similar like a game engine. Instead of a two-dimensional screen, they wear a goggle and it's a VR or XR environment instead of a two-dimensional rendering. So creating Metaverse platform is similar, very similar, like creating MMORPG or MORPG games in Unity. Once you created the MMORPG game, you can just replacing the rendering output with the XR or VR devices. You can create a very similar environment like Ready Player One. And in the Metaverse world, there are 6 pillars of Metaverse ecosystem, which is cited from other paper. And the first of all, there are avatar and content creation must be possible. And there are virtual economy, and there are social acceptability. And there are also security and privacy, and trust and accountability is the 6 pillars of Metaverse ecosystem. But as an engineer, we need to know the pillars for technology. And this is 8 pillars of Metaverse technology. There are network, means that creating servers and something like that. And also edge cloud computing, artificial intelligence, computer vision, blockchain, robotics and IoT, and user interactivity, and also extended reality. So Metaverse platform need to include all these stuff. So because in a short time, we can't develop everything. So in our cases, we focus on networking and some artificial intelligence, and our goal is just opening ceremony for upcoming event. It's our first goal. So how can we create this kind of Metaverse platform? So creating Metaverse platform is very similar like creating MMORPG game server. So I drew a basic structure of Metaverse platform. And there are multiple clients, and there are also multiple server, and each client need to connect to the server. And each server is also connected to databases, and this is one database. And to manage multiple game server, a central server is also connected to each game server. Generally, when we created the game server, the maximum concurrent user CCU is 2,000, and DB can manage 10,000 CCU or 30,000 CCU. So it means that 10 game server or 30 game servers are connected to one databases. And sometimes we need to move a client from one game server to other game server. And to do that, one center server is connected to all the game server, and the server related communication is handled by this center server. And that means that we need to create a client and game server and databases and center server. So it's a very big project. Fortunately, there are some open sources for game server and databases. So if you use that open source, you can create a MMORPG game within, I think, 6 months or 3 months. And this is a sample MMO server. Actually, this is cited from the official document from my previous company. So there are login server, center server, and user connect to game server and channel server. And channel server, game server are exposed to client, but login server and center server is not accessible by client. And multiple game servers are managed by global server, and all the game server is connected to same databases. So we need to create login server, center server, global server, and chain server. But when we started creating our own DSU Metaverse, I found sources, open sources, which they already implemented this kind of servers. So I started using that one. But as a student, you need to understand how to create this kind of server from scratch. You may use Java or C# or C++, but anyway, you need to create your own server from scratch. But after graduation, don't do that. Use existing sources, or when you enter the company, you can see the already existing sources and very big, and just try to understand the sources. But in the university, as a student, I recommend try to create your own game server from scratch. So this is a open source list Googled in source port. So actually, I considered this kind of sources, Trinity Core, some other sources in there, and this is written by C++, and this is written by Java. But I want to work with Unity. So as you know, Unity uses C#, and C# is not compatible with C++. So you may create some intermediate connector between C++ and C#, but it takes time. So I want to use a C# server, which works with Unity. But for a student, in our university, there are lectures which create ML game servers. So if you are a student and interested in being a game server developer, I recommend this source repository. And if you visit github.com/gp101 and Beacon server, and you can see step-by-step sources, and also there are lecturing videos for these sources. And you can download these sources from GitHub, and you can watch videos for this source. And this is basic structure. And if you are not good at multi-threaded programming, you need to be familiar with the multi-threaded programming, because all the server uses multi-threaded programming. And this is basic structure. And in here, as you can see, network layer, user layer, database layer is completely separated, and they only communicate via message queue, because each layer has their own multi-thread are working, and between multi-thread to decrease the accessing the critical section, generally they use a message queue. And all these stuff are well explained in the lecture. So I recommend these lectures. So if you want to be a game server developer, please download this source to your desktop and watch these videos, okay? And this video will explain all the required stuff for the game server developers. But I didn't use this source code because this is basic explanation for game server, but I need all the stuff which works for Metaverse platform. And next basic stuff is rendering engine. Okay, rendering engine means that draw 3D object into two-dimensional screen. And also there are a bunch of open source rendering engine out there. One of them is Ogre. And Ogre is still popular, and some of them still uses Ogre. But unfortunately, Ogre only contains the rendering engine. It does not contain physics engine and AI engine. So, but in some cases, they already have their own physics engine and AI engine, and sometimes they use Ogre. But now, as I know, all the games just uses Unreal or Unity engine. But to understand the detailed implementation, and if you want to build your own rendering engine, Ogre is a good starting point. And to understand the complete picture of rendering engine, you need to get the lectures, computer graphics courses. In that courses, in your university may cover all the topics which is related to rendering engine. And this is some of the topic: object-oriented interfaces, extensible examples, frameworks, and render state management, Direct 3D 911 topic, and vertex shader, fragment shader, and currently geometry shader and curve shader, And OpenGL uses CG, but DirectX uses HLSL, and multi-texturing, branding, LOD, texture from image file, and projective texture support, and also mesh support. There are a bunch of mesh format files out there, and the rendering engine needs to support all those formats. And by quadratic Bezier patchy and progressive meshes for LOD. And this must be implemented in rendering engine. And also for animation, skeletal animation and animation blending and morphing, and the managing scene nodes for animations, and managing camera paths, and for scene features, flexible scene management, and multiple shadow rendering technique, and special effect for compository system, particle system, billboarding and ribbon trailing, and transparent object management, and flexible plugin architectures. So all these stuff must be implemented for rendering engine. But we didn't have enough time to implement all this stuff. So I recommend, if you are a student, I recommend you need to implement your own rendering engine from scratch with Java or C++. And I recommend this course. And also this course is lectured in our university for the third year student. And in this sample rendering engine, we used the C++ in Windows platform. And we implemented from scratch. We implemented pixel drawing, line drawing, and the affine transformation, and transformation, linear transformation, and finally, texture map, the 3D cube is rendered. And this is step-by sources. If you download the sources from GitHub, you can check step-by-step sources. First, we implemented empty window, and we drew line with vector, and explained the basis. And this shows the basis transformation, and explained the two-dimensional matrix, and explained the matrix multiplication. And as you know, matrix multiplication is not commutative, and it explains with animation. And homogeneous matrix means that we use the 3x3 matrix for two-dimensional transformation. And this is why it is called homogeneous matrix. And to define polygon, we need to use vertex buffer and index buffer, and simple 3D projection into the two-dimensional screen. And finally, 3D cube is projected on two-dimensional screen with a perspective projection with a hidden surface remover. And next step, we need to add colors for the faces. And to do that, explain scan conversion, implemented scan conversion, and add the shading, and finally add the texturing. And also, we prepare the video lectures for this rendering engine. And this rendering is just for understanding. It's not so fast because it's based on Windows GDI, but it's enough for understanding the basic features of rendering. And there are lots of features out there for rendering engine, but if you completely understand all the sources up to here, next, the more difficult stuff maybe run later. So I mean, this is the most fundamental part of rendering engine. And if you download these sources to your desktop, you can launch that. You can test that simple rendering engine, and I show you. And if you download the understanding Unity and under linear algebra, because most of the topic of rendering engine related to linear algebra. Under Windows Win32, you can launch a sample rendering engine. Yes, in here you can see a 3D texture rotating cube. And for this rendering engine, we didn't use the DirectX or OpenGL because we implemented everything. So try to understand all the sources in this Pioneer source code, and it will convince you the understanding for all the difficulty of 3D API. So you need to understand rendering engine. And the next topic to create Metaverse platform is physics engine. So I know all the game engine, Unreal and Unity already contains the physics engine, but we are a student, so we need to create our own physics engine. but even its basic level, I recommend try to create your own physics engine. And this is Bristol real-time physics engine. And here you can see Box2D, Physics X by NVIDIA. Amazingly, Physics X is an open source physics engine. And this is the Physics X description. So at 2001, it's a Novodex AG. So I started my company 2000, and to create our own physics engine, we also repaired this source code. But now, after it's acquired by IKEA, and now it's acquired by NVIDIA. And so if you use Unity, Unity default physics engine uses Physics X. And also there are popular physics engine, Havok. And Havok is also acquired by Microsoft. And in Unity, you can also use this Havok. It's not the standard package, but it's an external package. If you import this Havok package to Unity, instead of Physics X, you can use Havok. And also there are 2D based physics engine. And this is also basic code for 2D physics in Unity. And as I know, Unreal Engine also uses Box2D for their 2D physics engine. And this is open source. And you can download Box2D source from this site. And there are good documentation exists, and you can read them. But if you try to analyze a source code from Box2D, because you are not familiar with the physics stuff like torque and impulse and angular momentum, and also tensors and something like that, in my case, it's almost impossible to implement the sources. So I started preparing, which explains Box2D. And I analyzed Box2D source code and copied the very basic part of Box2D, and I made a more simpler 2D physics engine. But it's based on Box2D. So you can download more simple 2D physics engine from GitHub. And I recommend, if you are interested in making physics engine, download this source code and watch videos for this source code. And in this source code, first step, we create a point cloud. And next step, create convector from source point cloud. And explain linear momentum. In linear momentum, I didn't consider torque. So if you add a linear momentum for rigid body, it only moves linearly. And next step, consider torque. Torque means that angular movement. And when there are collision, first we need to find the collision. It's called collision detection. And for collision detection, you can use SAT. And this shows how SAT works with the animation. And collision response is adding impulses for opposite direction when two rigid bodies collide with each other. And finally, add a friction for 2D rigid body. And this is final implementation. So because I prepared the step-by-step sources for runners who want to develop their own physics engine, and this is more easy to understand than Box2D. So try to understand the step-by-step sources. And also there are videos for this 2D physics engine. And if you visit this site, YouTube, you can see the prerequisite for physics engine. So unfortunately, I didn't prepare the actual lectures about 2D physics engine, and this is prerequisite stuff. So I had a lecture, but I didn't prepare the online lectures for students. And there are video lectures, and I show you 2D physics engine demo. If you download the GitHub sources, you can see step-by-step sources up to 6. And under Win32, this is the final implementation of 2D physics engine. In this 2D physics engine, it's also based on Windows GDI, and all stuff is implemented from scratch. If you press, after create a point cloud, if you press a spacebar, it creates a 2D rigid body like this. And inside rigid body, press right button and set direction, and it adds impulses to that direction. So, and create more rigid body like this. And also I apply the southern end, the polygon clipping algorithm. And also there are a bunch of documents out there. So if you try to understand from step 1 to 6, finally you can understand how physics engine works. And next basic pillar for Metaverse platform is AI. And in your university, you may run the AI stuff in the course. And also our university has a bunch of AI classes out there. So you need to get all the AI stuff. So in my case, when I started to running AI stuff, the first hurdle is calculus. So try to familiar with the calculus, differentiation and integration. You don't need to be a professional at calculus, but you need to understand basic stuff of calculus. And this is why in computer engineering department for computer scientists, the calculus and the general mathematics, linear algebra, and computer graphics, databases, and servers courses prepared for your student. Okay, so what's the answer to create a metaverse? So as you know, we need to create rendering engine, physics engine, AI engine, and all other stuff. But we didn't have enough time to create that one from scratch. But fortunately, there are commercial game engine. There are Unity, Unreal, and other game engine. But as I know, the most two popular game engine is Unity and Unreal. And most of the mobile app uses Unity, but Unreal, in some aspect, Unreal is more powerful than Unity. But I prefer Unity. I worked 16 years with C++, and that means that I'm more familiar with C++. But once I started with the Unity, C# is more, how can I say, so more not error prone. In C++, you need to manage memory by yourself, but in Unity, you don't need to manage it because it's managed by the Unity engine, the C# engine. So, and there are more higher concept exist in Unity. And in Unity platform is more easy to access for the beginner developers. So if you are not didn't experience with the Unity and Unreal, I recommend try to use Unity, but it depends on you. So in the university or in the YouTube, you can see many videos which explains the Unity features and Unreal features. I think this is the intermediate level. But to start implement your own metaverse, you must be a professional at Unity or Unreal Engine. So in my case, I'm already professional in Unity. So you try to familiar with all the features of Unity to create your own application or your own app, which works for mobile devices and other devices. Okay, so I'll skip this part. Okay, but you need to understand all the features. All the features of Unity. There are built-in packages and third-party packages, and some of them are very great too. And if you are not good at Unity, even if it already exists in Unity, you start developing your own. Don't do that, okay? So try to familiar with it, all the features of Unity. So I'll skip this intermediate part. So I assume you already familiar with the Unity. Then let's start our own metaverse. And we will call it DSU Metaverse. DSU stands for Dongsu University. And we started creating our own metaverse system 3 months ago. And I show you current status. First, server. So I checked some servers, which is a paid asset or open source. And first candidate is UMMORPG. And second candidate is Photon, and third candidate is Atavism. And finally, I choose Atavism. And there are some reasons why I choose Atavism. One of them is that in Atavism, they already created databases and the servers, and also there are services which automatically install the working server into the cloud platform. So with one click, I can install Atavism server and databases into the cloud platform, and we don't need to spend the time to develop a server. So I choose Atavism. but you need to pay monthly, maybe $3 per month. And also it's configurable. Core part, many part of the server can be configured by developers, and they use Python language to configure some features of the server. And that means that even if the server working, and you can configure and you can modify some operations of the server. So we started using Metabolism for server. And also I investigated every available packages before start from scratch, before implement from scratches, because many of the packages are well run, and some of the packages are very great. And if you use the packages, we don't need to do everything. So I investigated some packages, and this is package list for our DSU Metaverse. And first of all, we use the Pro Builder, and Pro Builder we can create your own meshes in Unity. So for dummy building or prototyping, or some good messy modeling can be done in Pro Builder. So you need to understand Pro Builder. And also there are built-in terrain editor. With this editor, you can create terrain trees and details of your terrain. And also 3D with the 3D web view, real-time YouTube streaming can be rendered in your game. So we will use 3D web view, and it's also paid asset. And we started starter asset, third-person character controller, and UMA2 for multi-purpose avatar, and I2 localization for localization, because we use Hangul and other country uses English or their own native language. And also for terrain, I downloaded terrain texture pack, and also we use World Composer. So our university located at mountain, and we need to get exact information of terrain. And to do that, we started using World Composer. And with this tool, you can create exact information of your terrain. And also we use Gena Pro to create road and curves and some pencils. And also for Power, I downloaded Grass Power Pack Pre. And this is actually all the packs we downloaded to create our own metaverse. And also download pre-speed tree package. I didn't have no time. So some pre-bushes and rocks and modular maze, it's a paid asset. Because our university, there are this kind of words out there. And also I downloaded AutoPens World Builder. And also I think this is very great tool. And there are more than 100 ready-made pencils out there. And you can pick your own pencil style, and you can locate in your Unity environment. And for dummy building, download the city pack. And also when I downloaded some complicated model, I need to remove some unnecessary mesh part. And to do that, I also use Mantis LOD editor. And to check the performance, I also downloaded advanced FPS counter. And so to check the error situation, for example, in Unity, when some component is missing, it causes a problem. So we need to find that kind of problem. So to do that, we also use this maintainer. And with the mesh cutter, we can cut part of the mesh. And with object editor, we can edit existing mesh. And for pivot editor, to change the pivot position for when mesh is loaded. And also with the town constructor 3, you can create a building and some houses with this tool. So we use all this tool. And we need to prepare develop environment, because we have our own team to create the DSU Metaverse. First of all, we need to prepare Devops. So in our university, there are available NAS systems, so we installed the Git server. Okay, so I didn't have enough time, so I skipped. So we created a patcher, because the need to if you launch your Metaverse application, if there are new stuff is available, you need to download them from patch server. And also for this purpose, I Googled and found some open source, and I downloaded and modified this source to implement our patcher. And also we need to prepare patcher server. And for patcher server, we created a WordPress in Apache with MySQL, installed WordPress and upload the patch contents in this web server and download patch contents from this WordPress web server. And installer, we need to distribute our installer, Metaverse installer, to other co-workers and other people. And to create the installer, I use the Inno setup. It's also open source. And also we developed our own tools, and it's an editor extension. And through machine normal, edit word transform, and select by tag is developed to check the validity of our source code. And the next, if you subscribe Atavism, you can download Atavism package for Unity, and in the cloud, Atavism server databases work in cloud. And if you download Atavism package, this package has a sample which connect to the running Atavism server. So you need to install Atavism package to your Unity. And this shows that how I installed Atavism package to Unity 2019. And I skip because there are tutorials if you subscribe Atavism services, and you need to set databases and servers and test servers and database connection, and also prepare a database backup for later recovery. And that means that you need to know how to work with the databases and servers. And I already back up the current database for later recovery. And also to use the UMA package, the Atavism already implemented the UMA2 package, which works with Atavism demo. And I installed the UMA2 package for Atavism. And this is the working screen. So I can connect to server, and it displays the character selection screen. And also I installed I2 localization. Default language is English, but I want to use Korean. So I installed I2 localization package. And you need to enable I2 localization. And when I tested Korean, it's not displayed. It's displayed like this. So I need to know the solution. And I finally found the solution. And so the solution is you need to install the native language file to your Unity project. And finally, the Korean is rendered properly. And also, there are Atavism WordPress plugin. So if you connect to Atavism server, it asks you create an account or not. But if you install WordPress and Atavism WordPress plugin, account creation may be done in this website. And then when player connect to the Atavism server, it only checks the account is already created in web page or not. And then you can separate account creation and server management. So we started using Atavism WordPress plugin in our website, the test website. And this shows that the progress. Yes, so I'll skip the other part. And also this shows that how the Atavism server works with the existing web server. So with all this knowledge, we started to developing our own, our university. So our goal is to create a digital twin of Dongsuh University. Yes, so Word Composer, you can get exact real world data. And with this tool, you need to get Bing Maps SDK. And if you apply Bing Maps SDK, you can select an area of our planet, and then get data, real world data. So this is our university. And I selected 1,000 kilometer by 1,000 kilometers. And it's converted to Unity terrain. And I have this terrain. And so here, as you can see, it's jagged like this because it's not precise. The minimum resolution is, as I know, is 2 meters. So they are jagged line like this. But in Unity terrain tool, I use a smooth height tool to create this kind of terrain. So finally, we get exact terrain information, real world terrain information of our university. And next up, we need to get road information and world information. And also there are open services. If you visit OpenStreetMap, you can get real world building data and road data. And I made an account and I found our university and I downloaded building information and road information. And this is that message. And it is imported to Unity and it's overlapped with the terrain. So in this way, we have exact terrain information, building information, and road information. And now we can create a digital twin with this information. So this shows that how we created our university with that tool and with that packages. And this is a basic terrain, and I placed a main character and trees with the Unity terrain system, and also debris and flowers. And this is also part of the Unity terrain system. It's amazing. With the Unity terrain tool, we can create this kind of scenery. And then with other tool, so with Gina is a paid asset. We created the road and curves and the sidewalks. Okay. We created this kind of road and terrain, roads and curves and sidewalks. And next, we placed the dummy building, and this is made with Pro Builder. Okay, we need to check the bird's eye view of our university. So before locating actual building, we created this kind of dummy building with the Pro Builder. And Pro Builder is a built-in message generation tool, message editing tools. You can create any kind of message Pro Builder in Unity. And with the auto pencil generator, we created the pencils and props. So here you can see pencils created, and also here some props is also created like this. And finally, for actual building is located instead of dummy building. So I can't make this building because I'm a programmer, I'm not a modeler. So to get the actual model, it's worked by the exterior company by paying them. And we have 31 buildings in our university. So we paid them for building modeling. And this is final, the current output of our university. And I'll show you the demo. So if you run this one, and if you check the new version exists in the patch server or not, if there are no new version, it launches current version. And it launches this current version. And for now, it's most of the building is dummy, but if you press move with the basic character movement keys, WASD, you can navigate Dongsu University, the digital Dongsu University. And this is the university church. And here you can see some props, trees, and bushes. And this is all made by tool, by programmer, okay? And also there are fences and grasses and trees. And this is our main stadium. And this is our main stadium. Not so beautiful, but it will be replaced with more beautiful modeling. But to test, I downloaded some pre-assets for main stadium, and I located that stadium into here. And if you move to other part of the university, you can see other buildings and walls and rules and terrains is created like this. And I show the international building. And this is our international building. So in 3 months, we created this kind of metaverse because we use existing servers and databases, and we focused on creating only client part. In this demo, it only works in single player mode, but we already tested multiple servers can connect it together with the Metabolism server. So this is our current progress. And our goal is that we will make our own metaverse platform for our university. And other university may join with their own the digital twin of their university. Yes, this is it. Yes, yes. I lectured all stuff, and if you have any question,